Let's move on to example 5, part B we'll call it. Okay. Now you'll notice from the original question to the board, I did that rewrite. I want to remind you when we integrate there is not a quotient rule. So as in keeping with what we've done before, you'll notice that I brought that denominator up and gave it a negative exponent. So that should be a thing that would be familiar to you. Now that did transfer this into a product. But I'll again remind you, when it comes to integration, there's not a product rule either. So that rewrite that we're used to, okay, not a big deal. Substitution. I hope you recall when we did substitution that if we had a quantity being raised to a power, then that would be the logical thing to replace with the variable u. So notice this will be u to the negative third power. We've done that before. That was that that substitution assignment. And so this will substitute over as straight up u to the negative third power. And so this took the place of that. Substitution, if your x is complicated, it's got a lot of operations going on, it's got multiplication, you want to, for Calc 1, you try substitution. All right. Now let's build a dx. So we differentiate both sides with respect to x. This is where our derivative rules would come into play. And so I hope you remember them from the previous assignment. The coefficient, let's see, that term. This would be 2e to the power times the derivative of the power. That goes back to that previous assignment. Minus 0. I guess I'll put that there. Let's do a couple things moving forward. As we always do on this, we then clear the fraction by multiplying both sides by dx. And I would also suggest in the process that we clean this up a little bit. Let's go ahead and associate the 5 with the 2. 5 times 2, we've got 10 e to the 5x dx. So, clear fraction, clean it up a little bit. Now, look what fell in our lap. There's that e to the 5x sitting out there. The only problem is, instead of a 3, there's a 10. Big deal. We've talked many times about if you get a coefficient that falls in your lap and it doesn't match the original question, fix it. So, on this one, I think it's pretty straightforward. Why don't we cancel the 10 and replace it with a 3? So wouldn't multiplication of both sides by 3/10, wouldn't that manipulate this so it becomes that? We always want to build what's in the original integral. So things are pretty close to falling in our lap. Again, the e to the 5x, that was just good luck that it fell in our lap. And then we can fix the 10 and make it a 3. So this becomes 3e to the 5x dx. And you'll notice that will match the 3e to the 5x dx is now just simply 3/10 du. So we come over to the new integral, 3/10 du. And that's very easy to integrate because all it involves is our good old friend, the power rule, isn't it? And so, I don't know, I think this takes me back to that. But anyway, 3/10 n plus 1, that'll be u to the negative 2, over n plus 1, indefinite integral plus c. Let's clean it up a little bit. You can leave the negative exponent as far as I'm concerned. I guess the thing I would point out would just be to multiply this all together. So a positive times a negative, that'll be negative 3 over 20. U to the negative 2, if you want to put it back on the bottom, I don't care, and then plus c. Now, these will be worth multiple points, and I guess you would get all the points except for one if you were to end it right there, but to get the full credit, you need to remember that on an indefinite integral, you always substitute back. So therefore, this would become negative 3/20 u, which was the quantity, right? Come back to this, negative 2 plus c, there's your answer. All right, so that would be example 5, part B. Let's keep the party rolling here.